Okay, so today what we're going to do is just review on the fractional exponent worksheet from homework, question 7 and question 9, because there was a place that probably many of you got to, but you didn't get to the whole 9 yards of an answer. So I want to make sure that we all can get there. So number 7 had t to the negative 2/3 power times t to the 5/9 power. So again, we go back to our rules on exponents and monomials. And when I multiply monomials and the bases are the same, they both have a base of t, what do I do with the exponents? I add them. Okay, now I should see everybody writing things down because I have a strong feeling very few of you got the actual answer, that many of you got an okay answer. But we want to go beyond okay and get to actual. Okay. So what's the issue we have now with this problem? Yeah. The denominators aren't the same, and I cannot add or subtract fractions unless they have a common denominator. You know what's really funny is that you guys have this notion of common denominators, but you don't apply it in an adding and subtracting problem, but you'll find common denominators in a multiplying and dividing problem, which you don't need to have. So it's kind of funny how you got the idea you have to do this at one point, but you get it mixed up with what operations. All right, what's the common denominator between 3 and 9? 9. So we get 9 and 9. Now the second fraction already has a denominator of 9, so its numerator is not going to change. But the first one, I'm going to multiply top and bottom by 3, and I get a negative 6. Okay, so then I carry on. And what's negative 6/9 plus 5/9? Negative 1/9. Okay, so then I go ahead and I go back to radical form because I don't have enough t's to do anything with. And it's the 9th root of t to the negative 1st power. But then I have to remember from chapter 5, what does it mean when I have a negative exponent? What does that mean? Okay, Jason, we're doing this. Okay, negative exponent, Izzy? Yeah, it's the t is not happy being in a numerator, so what we're going to do is put him 1 over t, and that will make him happy. So now this becomes the 9th root of 1 over t. The problem is this breaks the rules. I'm not allowed to have a fraction under a radical sign, so I try taking the square root, the 9th root, of 1 over the 9th root of t. Now, believe it or not, we have two numbers that you can take to any root. What are the two numbers I can take to any root? And I know the answer. 1, 0. I can take 1 to any root and I get 1. I can take 0 to any root, I get 0. Okay. So here's where I'm at now. The 9th root of, or 1 to the 9th root is 1. And then I have the 9th root of t. So, how many t's do I have right now? 9. No, I don't have 9, actually. I have 1. How many do I need in order to take the 9th root? I need a total of 9. So how many more do I need at this point? 8. So how I rationalize this denominator is I don't multiply it by itself, because that only ends up giving me 2 t's. I multiply it by the amount of t's it's going to take to get to a total of 9. So I'm going to multiply top and bottom by the 9th root of t to the 8th. Why 8? Well, I already have 1 t underneath the radical. So multiply top and bottom by that. Now, I can't take in the numerator the 9th root of t to the 8th because I'm shy of 1 t. So that's going to stay as the 9th root of t to the 8th. The denominator, however, now looks like this. The 9th root of t to the 9th, which would be the same thing as saying t to the 9th to the 1/9 power. If I multiply 9 and 1/9, I get 1. So what I'm left with as my final answer is the 9th root of t to the 8th over t. And that's how I get that answer. Okay? So we have to remember these are just using all the rules we talked about in Chapter 5. All right, let's do number 9. This one had a to the 1/3 power divided by a to the 4/6 power. I'm going to rewrite that's way too small, sorry. I'll put the parentheses in after. So a to the 1/3 power divided by a to the 4/6 power. All of that raised to the 1/2 power. So when we had a similar question without the fractional exponents, but just normal exponents, what I noticed is that a lot of you decided, oh, I'm going to raise to the 1/2 power and deal with that first. The problem was that you guys raised the top to the exponent, but not the bottom. So I'm going to really caution you on this, that you follow order of operations. An order of operations says take care of what's in parentheses first. So if I'm dividing monomials and their bases are the same, what do I do with the exponents? I subtract them. So the first one is in front minus the second one. I'm not going to do anything with that 1/2 power till I get down to one exponent only in the numerator. Okay, now I have a couple options here. Option 1 would be to find a common denominator between 3 and 6, which would be 6. Or option 2, be smart about it and notice 4/6, I could simplify that. 4/6 shares out of 2, divide 2 out of each of them, and I get the 2/3 power. Now, here's the great news, is that now has the same denominator as the a. So when I take 1/3, take away 2/3, I get a negative 1/3. Now I'm ready to do power to the power. I'm not going to deal with the negative exponent yet. I'll deal with that in a minute. So then I get a to, oh, I don't need parentheses anymore. Boop. I'm going to have the negative 1/3 times 1/2, which gives me, these are all equals, a to the negative 1/6. Now's the time I want to go back to radicals, and I'm going to have the 6th root of a to the negative 1st power. Now this problem is starting to look like number 7. Negative 1st power means I need to put the a in the denominator, and now his exponent is a positive 1. Rule 2 says you can't have a fraction under radicals, so you got to try to see if you can take the 6th root of each of those values. Well, I can take the 6th root of 1, it's 1, but I can't take the 6th root of a. So how many a's do I currently have? How many? 1. How many do I need? 6. So how much is it going to take to go from 1 to 6? 5. So what I'm going to do is multiply top and bottom by the 6th root of a to the 5th. And again, what allows me to do this is I'm just multiplying by a value that equals 1. So in the numerator, I have the 6th root of a to the 5th. In the denominator, I have the 6th root of a to the 6th. Okay, and don't forget, we already know what this equals, right? It's taking a to the 6th and raising it to the 6th power. So we've got 6 times 1, 6 is 1. So my final answer is 6. Oh, sorry, let's try that again. The 6th root of a to the 5th all over a. Okay, so my expectation is that you can handle these problems. You just got to think a little bit more than we did when we were squaring.